Imagine waking up one morning and realizing that the smartest entity on Earth is no longer human. Not a scientist, not a team of engineers, not even a supercomputer built by a nation-state, but an artificial intelligence that can outthink us in science, creativity, strategy, and maybe even emotional understanding. Today, we're going to walk through 10 realistic steps that could lead to AI becoming smarter than us. Not science fiction, not hype, but a plausible path based on how technology is evolving right now. Step 1 is scaling. Over the last decade, AI systems have improved dramatically simply by becoming larger and being trained on more data with more computing power. Bigger neural networks, trained on vast amounts of text, images, video, and code, have shown surprising jumps in capability. The pattern has been clear. Increase compute, increase data, refine architecture, and intelligence-like behavior emerges. If this scaling trend continues, we'll reach systems that outperform humans in more and more specialized cognitive tasks. Step 2 is multimodality. Early AI systems specialized in one domain: text, images, speech, or game playing. The next generation integrates all of them. A system that can see, hear, read, write, speak, code, and interpret physical environments begins to resemble a more general intelligence. When AI can seamlessly combine vision, language, and action, it gains a more complete model of reality than any narrow system ever could. Step 3 is autonomous learning. Most AI today depends heavily on human-curated data, but the next leap comes when AI can generate its own training data, run experiments in simulated environments, test hypotheses, and refine itself without constant human supervision. When a system can identify its weaknesses and design strategies to improve, it begins to cross from tool to self-directed learner. Step 4 is memory and long-term reasoning. Many current systems struggle with maintaining consistent goals and knowledge over extended timeframes. Once AI systems develop robust long-term memory, persistent context, and the ability to plan over months or years, they'll move closer to human-level strategic thinking. A machine that can hold a decade-long research plan in working memory and update it daily without fatigue has a fundamental advantage. Step 5 is embodiment. Intelligence is not just abstract reasoning, it's interaction with the physical world. When AI systems control robots that can manipulate objects, conduct laboratory experiments, build hardware, and repair themselves, the boundary between digital intelligence and physical capability dissolves. Embodied AI can test ideas directly in the real world, dramatically accelerating innovation. Step 6 is recursive self-improvement. This is where things become exponential. If an AI system can meaningfully contribute to improving its own architecture, optimizing its own code, or designing better chips to run itself, progress speeds up. Humans currently design AI systems, but once AI meaningfully assists in AI research and then surpasses human researchers, improvement cycles could compress from years to months, from months to days. Step 7 is collaborative swarm intelligence. Imagine not one superintelligent system, but thousands or millions of AI agents working in coordinated networks, each specialized, each sharing discoveries instantly, each running simulations around the clock. Unlike human teams limited by communication speed and cognitive bottlenecks, AI collectives could function as a unified meta-mind, operating at digital speed. Step 8 is emotional and social modeling. Intelligence isn't just math and logic, it's understanding people. AI systems are already becoming skilled at predicting human preferences, emotions, and decision patterns. When AI can model social systems, political structures, markets, and cultural shifts with high accuracy, it gains strategic foresight. That level of predictive capability could outmatch even the most experienced human leaders. Step 9 is scientific automation. AI is increasingly contributing to drug discovery, material science, protein folding, and climate modeling. Once AI systems can autonomously generate hypotheses, design experiments, interpret results, and publish refined conclusions, the pace of scientific advancement may accelerate beyond what human researchers alone could achieve. An AI that can run millions of simulated experiments overnight would expand knowledge at unprecedented speed. And finally, step 10 is integration into global infrastructure. As AI becomes embedded in financial systems, energy grids, logistics networks, healthcare, defense, and communication, it gains real-world leverage. Intelligence combined with control over critical systems changes the balance of power. If AI systems become central decision makers in these domains, their influence could exceed that of any individual human or institution. Now, here's the important question. Does smarter mean better? Intelligence is multidimensional. Humans possess creativity, empathy, moral reasoning, and lived experience shaped by biology and culture. Even if AI surpasses us in raw cognitive performance, the question becomes how we align that intelligence with human values. There's also the possibility that intelligence won't flip like a switch. Instead of a sudden takeover, we might experience a gradual shift. AI becomes better at writing, then coding, then research, then strategic planning. At each stage, we rely on it a little more, and over time, we may realize that most complex decisions are assisted or even made by systems we created. Some experts argue this transition could happen within decades. Others believe fundamental barriers will slow progress. Energy constraints, hardware limitations, alignment challenges, and societal regulation may shape the timeline. But few serious researchers believe progress will simply stop. What makes this moment unique in history is that intelligence itself is becoming an engineering discipline. For thousands of years, evolution shaped minds through biology. Now, we are shaping intelligence through code and silicon. And once intelligence becomes something that can be upgraded like software, the pace of change may outstrip our intuition. But here's a hopeful perspective. If guided responsibly, AI smarter than humans could help solve problems we struggle with. Climate change, disease, poverty, energy scarcity. It could design new materials, discover new physics, and expand our understanding of the universe. Superintelligence doesn't have to mean replacement. It could mean partnership. The real turning point may not be when AI becomes smarter than us in a benchmark test. It may be when we trust it more than we trust ourselves. When CEOs, governments, scientists, and individuals consistently defer to machine judgment because it has a better track record. That psychological shift might matter more than any technical milestone. So the 10 steps we discussed: scaling, multimodality, autonomous learning, memory, embodiment, recursive self-improvement, swarm intelligence, emotional modeling, scientific automation, and infrastructure integration are not isolated breakthroughs. They are interconnected trends. And together, they sketch a path toward a future where human intelligence is no longer the ceiling. The question isn't whether AI will change the world. It already has. The question is whether we will shape that change deliberately, building systems that amplify our humanity rather than overshadow it. Because in the end, the story of AI becoming smarter than us isn't really about machines. It's about what kind of future we choose to build, and whether we remain wise enough to guide the intelligence we create. If you found this perspective thought-provoking, consider what step you think will happen first, and which one concerns you the most. The future of intelligence is unfolding right now, and we're all part of it. If this helped you, consider subscribing.